So which of the following is an electrolyte, and how would we know? Metal and nonmetal? Or metal and a polyatomic? A poly and a poly? Huh? So which ones are these? What's going to be the... Also, go ahead and write out beside there that HCl or HCl would be one. So acids and anything that's like a metal and a hydroxide group, those are our bases. Those are also electrolytes. So now I want to describe the process of making 1 liter of a 1 molar NaCl solution. So how are we going to do this? I told you, go in the lab and go do this. What's your first step? Okay, M equals moles over liters. We know it's a 1 molar solution, and I told you to make 1 liter. So how many moles do we have? So 1 mole of NaCl. Can I go back into the lab and measure a mole of NaCl? We have to convert it to grams, so that molar mass of NaCl is 58.5 grams. So I need to go into the lab and measure out 58.5 grams of NaCl. And how am I going to measure that? Put it on the weigher?
Yeah, the weigher.
On the weigher. Put it on the weigher, better known as a scale or balance. So we're going to go mass that. What's my next step?
Oh, you use the volumetric flask.
Use volumetric flask. What size of volumetric flask are we going to use?
Medium.
Medium. Oh, a liter. So we use a liter volumetric flask. We take our 58.5 grams. We dump that into our volumetric flask. Now what? Stir it. We're just going to stir solid?
Yes.
Heat it up.
Just no.
You're done.
What do we need to add?
Water.
Water. We're going to add water.
I thought we were.
Well, how much water are we going to add? At first?
No, wait, do where it adds up to.
Saturated. How much? Yeah.
What? Somebody say something? Am I going to fill it all the way up to the meniscus right away? No.
You have to add a little bit because then whenever you start mixing it, it's going to go whoosh.
Yes. Okay. It's going to go whoosh. So we got to add a little bit in there because those ions are going to spread apart. So once we get it all dissolved, then we're going to, I call it QSing. It's just a lab term that we use. You QS it up to that meniscus. And you're done. Some of you guys need to learn how to read a question because on that quiz, it says what 2 pieces of equipment, not 2 things are needed to make a solution. 2 pieces of equipment.
I guess.
Keyword.
Did I get it right?
I don't remember. Okay. So what we're going to talk about today are acids and bases. We're going through about 18 slides today. So the very first thing we're going to talk about is the definition. What is the definition of an acid? What is the definition of the base? And you have 2 different types of definitions. And you are responsible for knowing both types of definitions. So the first one is an arenous acid. They are on homeroom. They're under Friday's date. An arenous acid. This is one where we take it and when we add it to water, it increases the hydrogen ion concentration. So you're going to see me writing this a lot. Increase hydrogen ion, that's the H+, And those brackets mean concentration in the chemistry world. So it increases the hydrogen ion concentration. So what the heck does that even mean? No idea. Me either. I'm just kidding. Okay. All right. What are the two things that compose of water? Hydrogen and oxygen. And remember when I told you that you could write water this way? Water is composed of hydrogen ions, and water is composed of hydroxide ions. So, hydrogen ions and hydroxide ions. So, if I were to have this beaker full of water, some of the water is going to be intact. Okay, so we have H2O molecules floating around in here. But we're also going to have a little bit of H ions and OH ions floating around. So if I were to take an acid, so we're going to take HCl. That is an acid, and I am going to put it in here. What's going to happen is it's going to ionize. And when it ionizes, we're going to end up getting some H pluses. And then what we're also left floating around with are some Cl minuses. So when I added that acid in there, what happened to my number of H's? I started out with 2 H's, and I ended up with 4 H's. So my H concentration went up. That's what makes an acid an acid. A Arrhenius base is when we add it to water, what happens, is we are going to increase our hydroxide concentration. So now this time we have our water. We have H2O floating around in there. We have some H pluses. And we have some OH minuses. And if I take a base and I put it in there, now we end up with some Na pluses because it ionizes, and we end up with some OH minuses. So we increase the OH concentration. Questions on that? So these are pretty basic. If you see all acids start with H, whether it's this definition or another definition, they all start with H. But in an Arrhenius base, they all have OH. It's a metal and a hydroxide together. Okay? So don't be fooled by something that has a formula something like this, and it has the OH in there. You might be fooled to say that that is a base because of this OH. But this portion right here has to have a metal there, or a polyatomic. Water is an acid and a base. Water is both. So this is actually an alcohol. So big difference between an alcohol and a base. Okay, so let's classify these. First one, acid or base? And you're going to see I'm going to use some color coding because that's going to help us in the next portion. HNO3, acid or base? Next. 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 All right. Any questions on those? Pretty simple. Okay. So now we talk about Bronsted-Lowry. So Bronsted-Lowry the definition of this says that when we have a Bronsted-Lowry acid, it donates a hydrogen ion. It donates a hydrogen ion. The Bronsted-Lowry base will accept the ion. And you're going to see that I am going to call those protons. Because that's basically what it is, okay? It's a hydrogen atom with no electron, so it's a lone proton. So we either accept or donate protons in Bronsted-Lowry. Any questions over that? Okay. Everybody good? Okay. So here is a picture showing if we have an acid and a base. We see here that we have these two neutral molecules, HCl, and we have water. They're both neutral. What happens is this H gets donated over to water. When we donate an H plus, what happens is now water gains a hydrogen and is no longer neutral. It now has a positive charge. Now, HCl, when it donated that H, Cl is left alone hanging out here, and it lost that positive charge from the H, and so now it's a negative chlorine atom. Huh? Okay. Any questions on that? So you've got to make sure you're writing those positives and those negatives there when you lose or gain a proton. Again, this one is showing it water acting like an acid this time, and what we are left with. So here we have NH3, NH3, and we have H2O. So water gives up an H, and when water gives up an H, NH3 becomes NH4. It's no longer neutral. It's now a positive charge, and OH lost an H, so now it's negative. Okay, so right somewhere, I don't know if I wrote this in the notes anywhere, water is what we call amphoteric. Water is amphoteric, which means it acts both like an acid and a base. So that's what amphoteric is. You act like an acid and a base. No, it's not. There's other things that do. It just depends on the situation that it's in, what's available. Okay. Huh? I only have to memorize water. We're going to see one here in a minute. So you see here, water is an acid. It can give an H away. Water is a base. It can take in an H. Yes?
Is that going to be like a homework question or something? Like what is it right now? Like is it an acid or is it a base?
Well, yeah, we're going to talk about that. Uh-huh.
Is it going to be like arrows or something?
No, not that easy. You're creative. Okay, so now here's a bunch of reactions. I want to know, those of you that took notes, or I've got left an O out here, and I left a negative out up here. I want to know, is it an acid, Bronsted-Lowry acid or base? So the very first thing is I look at the reaction portion, and I see what happened from NO here to here. Did it lose or gain an H? It lost. That means it is an acid. Because it donated. Donating is losing. That means water is acting like a base. You see water goes from here to here. It gained. So it accepted a proton. All right, NH3. NH3 becomes what? And H4. So did it gain or lose? Gained. Therefore, it accepted, which means it is a base. Which means water, in this case, is acting like an acid. H2SO4 goes from here to here. It lost. So it is an acid. So OH is a base. What about the next one? It goes from here to here. So it's a base. So water is an acid. What about from here to here? It lost. So it's an acid. So OH is a base. Now this one is amphoteric too. You see, here it lost one, but here what is happening? It gains an H. So now it is a base. Okay? Questions on that? So you must know how to classify those as either acid or base by are they donating or are they accepting? HNO3, is it Bronsted-Lowry acid? That's what we're talking about. Yes, it is a Bronsted-Lowry acid. Is it an Arrhenius acid? Does it start with an H? Yes, you can be both kinds, okay? Now, what about NH3? It's a Bronsted-Lowry base, but is it an Arrhenius acid? Or Arrhenius base? No, because it doesn't have the OH. Okay? So you have to look at that. You need to know those definitions and be able to classify those things. So here, this is a Bronsted-Lowry base, but it's not an Arrhenius base because it doesn't have OH in there. Okay, so this just kind of puts this into a T-chart. And then the next thing you need to know, you have your acids and your bases in a Bronsted-Lowry, but when an acid gives up a proton, it becomes a conjugate base. So here, HA, A is generic for acid. So here we have an acid. The acid donates a proton, so it gave up a proton. We start out with the acid, and it becomes the conjugate base. The water here is the base, and it becomes a conjugate acid. No. No, what that means is if I were to take this reaction and I were to reverse it, so now I'm starting out with this. A is what? A minus is acid or base? It's a base. So the conjugate base, when I reverse the reaction, now becomes the base. They just flip each other around.
So it is a
It's not amphoteric. I see what you're saying. But it's just the conjugate. It's just what a conjugate is what happens when it lost a proton. Okay? It's not acting both like an acid and a base. So you have to be able to say, oh, HA goes to A minus. So HA has to be my acid while A minus is my conjugate base. So you have to be able to classify acid and conjugate base. And base and conjugate acid. They go together. Again, here's another picture showing you that. And now we're ready to classify. So here's our reactions we did a while ago. HNO3 was an acid and H2O was a base. So what is the conjugate base? The acid becomes this. So that means that is my conjugate base, which means this is my conjugate acid. Here we have base and we have acid. So what is this one? NH4 plus. Conjugate acid. OH is conjugate base. H2SO4 is my acid. This is my base. So HSO4 minus is what? Conjugate base. And water is my conjugate acid. We said a while ago this was our base and this was our acid. So OH is our conjugate base and this is our conjugate acid. Here we said that this one was our acid and this is our base. So this is our conjugate base and this is our conjugate acid. And here we said this was our base and this was our acid. So H3PO4 is our conjugate acid and this is our conjugate base. Okay, on your homework it says, what are the conjugate bases to these compounds? So what you're given are acids, and you need to tell me what would their conjugate base be. You need to make sure something, like if it gave up a proton, you need to make sure you're putting a minus sign there. If it changes its, changes its charge. If it goes from neutral to something else. Okay? So this right here is review. You have already learned how to name acids. So naming acids, there are two types of acids. There are binary and oxy acids or tertiary. So binary is just two, an H and something else, a nonmetal. And when you name it, you're going to say hydro, your root, ic acid. So hydrobromic acid, hydrofluoric acid, hydroiodic acid. Now, if it is a tertiary or it's an oxy acid, which means it has oxygen in it, you're going to have to look at the polyatomic ion. So if the polyatomic ion ends in 8, it is just going to be, if we have chlorate, chlorate becomes chloric acid. We dropped the hydro. Okay? So we would have had hydrogen chlorate, but it becomes chloric acid. We may have hydrogen sulfite. Hydrogen sulfite, if you want to name it correctly, is going to be sulfurite becomes sulfurous acid. You drop the hydrogen on that one. Okay, so remember, I ate a humongous bite. So I ate humongous bite. Questions on that? All right, moving on. pH scale. You guys have seen this before, right? Huh? Swimming pools and stuff, yes. It ranges, and if you took your notes already, that should say 0 to 14. It ranges from 0 to 14. If I go from 0 to 7, up to 7, that is my acids. As I go from 7 down to 0, I'm getting more acidic. Okay, you're getting more acidic. 8, alkali is the same thing as a base. As I go from 8 or 7 up to 14, I get more basic. Okay, 7 is neutral. You need to know that sometimes you're going to have it below 0. You might have a negative 1.4 pH. Or you might have a positive 14.9 pH. That there is stuff outside that range. It's a scale. It's not exact, okay? So things might fall outside that scale that we're used to seeing. Just know that that does happen. Any questions about the pH scale? Tomorrow we're going to calculate pHs. Okay, so here is a list. You can see battery acid. Your stomach acid is a pH of 1. Lemon juice, vinegar, pH 2. Grapefruit, 3. Tomato juice, acid rain. Soft drink, black coffee, pH of 5. Urine and saliva is 6. Pure water, 7. Then you have seawater, baking soda, milk of magnesia, ammonia, soapy water, bleach, oven cleaner, liquid drainer. All that stuff is basic. Okay? So, properties of acids. 1, they have sour taste, right? You guys like those sour gummies or whatever? Those sour extremes, those... Yeah, they put a bunch of different, citric acid. So those are acidic. What is going on is they're donating hydrogen ions. They react with active metals to form hydrogen gas. So if I were to have hydrochloric acid and I have magnesium, what happens is we're going to get hydrogen gas formed. So we're going to get this start bubbling up out of our reaction. And then we're going to get magnesium chloride as our solid. pH goes from 0 to 6.9 or can fall below that 0. And then one thing else I want you to know is litmus paper, which we'll really talk about tomorrow, but this is on your homework. Litmus paper is a pH indicator. And what acids do is it turns litmus paper red. So if I have red litmus paper, litmus paper is red or blue. If I have red litmus paper and I put it into an acid, it stays red. If I take a blue litmus paper and I put it in an acid, it turns blue. Or it turns red, sorry. So litmus paper turns red. Acid, red. Okay? Questions on that? All right. Bases. Bases. Anybody know how bases taste? They are bitter. They are slippery to touch. So soaps. And, like people, I'm going to wash your mouth out with soap. You know that scene in The Christmas Story? And he's like, bah, bah. Okay, bitter taste. They donate the hydroxide ions. pH is 7.1 to 14. Can be above that too. But big thing too that you need to know is that we turns litmus paper. What color do you guys think? Blue. Bases, blue. Okay, so blue litmus paper, if I put it in the base, it stays blue. If I take red litmus paper and put it in a base, it turns blue. Questions? Is the next slide indicators? Yep. That's it. That's all I'm stopping. So your homework tonight is acids and bases, the first 1 through 12, except for 9 and 10, unless you've already gone through the notes and you know the answers to 9 to 10. All right, tomorrow, come prepared. Bring a calculator or grab a calculator as you come in.